Welcome to the lesson on normality. The first statistical assumption is normality, which requires that the data for both variables are distributed in a bell-shaped distribution. As Pearson's correlation is a parametric test, the assumption of normality applies. However, as Spearman's correlation is a non-parametric test, there is no assumption of normality. Therefore, we will only need to assess normality when performing a Pearson's correlation. There are many ways to assess normality, and we will review 3 common methods. Shapiro-Wilk statistics are appropriate, especially for small samples. Central limit theorem is appropriate for large sample sizes. Normal QQ plots, detrended QQ plots, and histograms are useful for visually inspecting the shape of the data. We can test normality objectively in SPSS using the Shapiro-Wilk statistics. When the sample size is small, for example, less than 30 participants, the Shapiro-Wilk statistics can be reliably used to establish normality. However, it is important to keep in mind that when the sample size is large, for example, greater than 30 participants, Shapiro-Wilks can be overly sensitive and significant results may be derived even when there is a small deviation from normality. Let us take a look at an example with a small sample size. For normality to be met, the Shapiro-Wilk statistics should not be significant. For insomnia, the p-value is 0.720, which is greater than 0.05. Therefore, the assumption of normality has been met. For depression, the p-value is 0.843, which is also greater than 0.05. Therefore, the assumption of normality has also been met. The Shapiro-Wilk statistics were not significant for both variables. Therefore, we can conclude that normality has been met, supporting the use of a Pearson's correlation. The following test of normality table illustrates significant Shapiro-Wilk statistics for both variables. For insomnia, the p-value is 0.046, which is less than 0.05. Therefore, the assumption of normality has been violated. For depression, the p-value is 0.014, which is also less than 0.05. Therefore, the assumption of normality has also been violated. The Shapiro-Wilk statistics are significant for both variables. Hence, we can conclude that normality has been violated. In this case, we would switch to performing a Spearman's correlation instead of a Pearson's correlation. We would also switch to performing a Spearman's correlation if only one of the two variables were not normally distributed. When the sample size is large, for example, greater than 30 participants, we can apply the central limit theorem and assume normality. This is because the central limit theorem establishes that the sampling distribution of the sample mean of any independent random variable will be normally distributed if the sample size is large, for example, greater than 30 participants. To assume normality based on the central limit theorem is easy. All we need to do is ensure that our sample sizes for each variable is greater than 30 participants. We can also assess normality subjectively using graphs. 3 graphs are commonly used to subjectively assess normality, and these include the normal QQ plots, detrended normal QQ plots, and histograms. 2 examples of normal QQ plots are provided. The left depicts normality being met, and the right depicts normality being violated. In the first graph, the data points are clustered closely around the diagonal line, indicating the data is normally distributed. In the second graph, not all data points are clustered closely around the diagonal line. Specifically, those that are circled are further away from the diagonal line, indicating that data is not normally distributed. 2 examples are also given for the detrended normal QQ plots. The left depicts normality being met, and the right depicts normality being violated. In the first graph, there is roughly an even amount of data points above and below the horizontal line, indicating the data is normally distributed. In the second graph, there is not roughly an even amount of data points above and below the horizontal line. Specifically, there are more data points above the horizontal line than below the horizontal line, indicating the data is not normally distributed. Lastly, 2 examples are given for the histograms. The left depicts normality being met, and the right depicts normality being violated. The first histogram looks similar to a bell-shaped curve. We can conclude the histogram also reflects a normal distribution. The second histogram is skewed to the right rather than looking like a bell-shaped curve. We can conclude the histogram also does not reflect a normal distribution. It is good practice for the student researcher to get in the habit of subjectively inspecting normality in graphs. However, in reporting the results, we would usually only report the objective assessments of normality, such as Shapiro-Wilks or the central limit theorem. This concludes the video on normality.